This high-yield chemistry topic is guaranteed to show up on your MCAT.
Radioactive decay is the process by which an unstable parent nucleus emits energy in the form of radiation, thereby converting itself to a more stable daughter nucleus. And in the process, there is always some sort of particle emitted. So alpha decay, the first one, is when you have emission of a helium nucleus. Okay, and this is what it would be written as. Now, the top number is the mass number, and the bottom number is the atomic number, right? So in alpha decay, the starting nucleus emits 2 protons and 2 neutrons, okay? So what happens to its atomic number? Well, Z is the atomic number, so we say Z decreases by 2, okay? And that, of course, changes the element to a different element because the atomic number, the number of protons, dictates what the element is. And then the mass number, which is A, decreases by 4 because there's 2 protons and 2 neutrons lost, so that's alpha decay. So next we have beta plus decay, aka positron emission. And so this is kind of the opposite of beta minus decay, where in this case, a proton in the unstable nucleus is converted to a neutron, and a positron, E plus, is released or emitted, okay? So what happens to the atomic number in this case? Well, Z here, okay, is going to be decreasing by 1. So Z minus 1, of course, which changes the identity of the element. And then, of course, the atomic number, or the mass number, does not change again, okay? And so these beta minus and beta plus, they're kind of the opposites, and it's easy to get them confused because you might think that, well, it's beta plus, so you must be gaining a proton, and beta minus, you must be losing a proton. But you need to think about it in terms of what's emitted. Beta minus is emitting an electron while a neutron is becoming a proton, right? Whereas beta plus is emitting a positron, that's where the plus sign comes from, while a proton is converting into a neutron. So a less often talked about form of radioactive decay is electron capture. And this one is kind of similar to beta plus decay, except in this case, an inner shell electron, okay, an inner shell electron actually is captured by the nucleus, hence electron capture, and a proton in that nucleus combines with that electron to form a neutron. So what's happening in terms of the atomic number? Well, ultimately, the proton is being converted to a neutron just like in beta plus decay, so Z decreases by 1, the atomic number decreases by 1. But then, of course, the mass number, again, does not change because there is no net change in the number of protons and neutrons, okay? So it's very similar to beta plus. And lastly, we have gamma decay, which is my personal favorite, and in this one, you have an unstable nucleus, which simply emits a gamma ray, high energy electromagnetic radiation, without changing the number of protons or neutrons. So essentially the atomic number Z and the mass number A do not change, okay, unlike all the other ones. And that's why I like this one so much, because it's very easy to memorize. I'd like to take this time to invite you to my live workshop, which I am hosting on Thursday, June the 12th at 8 p.m. EST and 5 p.m. PST. In this workshop, I will be presenting to you in great detail my top 5 strategies for scoring a 516 or above on the MCAT. And these are strategies which I've developed over years of working with students preparing for the MCAT. And they are very helpful, and they could be of assistance to you no matter where you are in your MCAT journey. So I really hope to see you there. Please leave a comment and DM us if you want a link, and you can also check out the link in the linked tree of our TikTok bio. I really hope to see you there.